If number patterns were all there were to it, factoring trinomials would be easy. But we can see that this becomes more complicated when the first coefficient is not equal to 1. For an example of this, let's imagine again multiplying binomials that do not begin with leading coefficients of 1. So multiply 2x minus 3 times 3x plus 1. What's my result? 6x squared minus 9x plus 2x. Minus 9x plus 2x. That gives me negative 7x. Finally, I have negative 3 times 1 is minus 3. So the relationship here is not as straightforward between the beginning factors and the ending trinomial. Certainly this pattern is still here, that the first terms multiply to make 6x squared, the last terms, negative 3 and 1, multiply to make negative 3, and the outer terms plus the inner terms sum to negative 7x. But because there's this breakdown or this factoring of the 6x squared into 2x and 3x, we can't follow this rule anymore to say that if I'm trying to factor this trinomial, I'm going to look for two numbers that multiply to negative 3 and add to negative 7. Thankfully, there are several different strategies that we can use for factoring when the leading coefficient is not equal to 1. One of them is just simply by trial and error. Trying lots of patterns where the first terms multiply to this coefficient and the last terms multiply to this coefficient, filling in lots of different numbers in the factors and multiplying it out to check your work. Trial and error works, it's just time consuming. Another strategy is called the AC method, and that's what I'd like to present in this video. So for this strategy, the first thing we do is multiply A times C, and then we play the number game, similar to what we saw when the leading coefficient equals 1, except now we're finding a factor pair of A times C that adds to B. Third, we're going to expand the middle term of the trinomial using this factor pair. And so instead of 3 terms, we're going to have 4 terms. And that means that we can finish by factoring by grouping. Let's look at an example or two of applying the AC method. So in the first example, the very first thing I want to do on the side is multiply out A times C. Here that's 4 times 9. So 4 times 9 is 36. And that tells me what number game to play. I want to find a factor pair of 36 that adds to negative 15. So they multiply to 36, they add to negative 15. Those numbers are negative 12 and negative 3. So we've identified that factor pair, but those do not go directly into binomial factors. Here's how this is different than the number patterns when A equals 1. We're not finished yet. We're going to take those and expand this trinomial into a larger polynomial with more terms using these numbers. So instead of minus 15x as the middle term, I'm going to write minus 12x minus 3x. I substituted this number pair that I found, and this still means the same as negative 15x. I've just expanded the middle part of the trinomial. That gives me 4 terms to work with. And I can factor by grouping. That's how we'll finish this method. Factor by grouping by pairing the terms, divide out the greatest common factor from each pair. So I look at 4x squared minus 12x, and the greatest common factor there is 4x. I write what's left, x minus 3. I look at negative 3x plus 9. The greatest common factor is negative 3. I factor that out. What remains is x minus 3. And here I can factor out a common binomial factor of x minus 3. So we have x minus 3 times the remaining pieces of these expressions, which are 4x minus 3. Here is our factored form of this original trinomial. Always check your work by multiplying, especially as you get started with this. Let's do one more example. Factor 2x squared plus 7x plus 3. So first, find A times C. In this case, that's 2 times 3, which equals 6. Second, find a factor pair that multiplies to 6 and adds to 7. That's pretty easy. It must be positive 6 and positive 1. Third, we're going to expand this trinomial using that factor pair. So we're going to write 2x squared plus 6x plus 1x plus 3. And fourth, we're going to factor by grouping. I pair the first terms together and factor out a GCF of 2x. X plus 3 remains. I paired the second terms together, the second pair together, and factor out a GCF of 1. X plus 3 remains. And finally, factor the greatest common factor of x plus 3. Collect what remains in the other factor, and here's our factored form. X plus 3 times 2x plus 1. If I multiply that out, that should give me 2x squared plus 7x plus 3. These are just two quick examples of using the AC method and factoring by grouping.